So hi, my name is Christian Bleim. I'm an industry technology specialist, basically technical sales. I cover SAP as an account. I'd like to spend a few moments with you today to talk about our latest generation of SUSE and scalable processors, including some of the features that come along, and mostly looking at the memory aspect of it. Looking back in history a little bit, about 10 years ago, we introduced the E series, and that was exactly the same time when SAP introduced HANA. And ever since, we've been partnering with SAP to optimize the HANA database, the CPUs, to make sure that the performance of the database is as customers would like to see it. You can see multiple generations. Year over year, you have the CPU performance increase. We're at the very right now. The latest generation was released only last month, on April 2nd, called Cascade Lake. It's got the same microarchitecture as the previous generation, but it's got some groundbreaking advanced improvements. So besides just constantly optimizing CPU performance, we spend a lot of time also in other fields. IoT is one of the important areas where we spend a lot of time on. We do edge computing, analytics at the edge, and feed the cloud. We also look at new technologies, which we'll spend some time on in this session, with memory, persistent memory. And also, we've spent a lot of time in the recent years improving machine learning and artificial intelligence. We've added instruction sets on the CPU that significantly accelerate specific workloads. So, let's look at some of the features that we bring with SUSE and Scalable family. You have, as a customer, a great choice. We basically work with every OEM out there. So you do not have a vendor lock-in. You can choose whichever vendor works best for you. We have a proven track record, as I shown earlier. We've been working very closely with SAP for the last 10 years to constantly improve and optimize the platforms. We hold a couple of world records, of course. We're proud. And scalability is a big factor. Both scaling up and scaling out is becoming more and more important for customers. Data grows and grows. The databases grow constantly. And TCO is a very important aspect, especially for the cloud folks too. Constantly improving the TCO of their cloud. And that leads me to the next slide. So it's traditionally we started off on-prem, but as you know, everything's moving into the cloud. So we support on-prem and cloud, hybrid cloud. We have solutions for the edge where you have smaller instances of HANA running perhaps. We support all the major operating systems that SAP need, most and foremost SUSE. And we work closely with big system integrators. It's an eye chart, but you can see all the major logos are there for now. I would like to point out the fact that one size fits all doesn't apply, as you know. Otherwise, it might be very expensive. There is this so-called Quick Sizer tool I'm sure you're familiar with. Quick Sizer is fully up to date with the latest generation of SUSE and scalable processors. So if you go there, you will find the latest generation called Cascade Lake. Plus, it also includes the Intel Optane DC persistent memory modules that I will talk to you about shortly. Yes?
Does Quick Sizer spit out saying that you should be using this much memory for the non-volatile versus the volatile one?
That's correct. So I'll repeat the question. So yes, the Quick Sizer tool does understand if it's DRAM, which is volatile, or if it's Optane DC persistent memory, which is persistent. So I'll spend some time on this as we go along. But yes, that's exactly why I'm pointing this out. The Quick Sizer tool is already up to date and understands that. So let's look at Intel Optane DC persistent memory, our famous tongue breaker. Some of the key important features are, first of all, you can see the form factor. You are used to different form factors when you think about storage, when you think about memory. Yes, DRAM. but not the persistent DRAM. But it comes in the same form factor. It's electrically exactly the same. You can run it in 2 different modes. Today we'll only focus on app direct mode, which supports persistency, but you could also use it as a normal DRAM. So if you're looking at larger capacities and you need those, and if you can see here, it's 128 is where we start. Second is 256, and 512 is the largest that we have with this first release. Next generation will even have 1 terabyte DIMMs. So you have those big capacities available to you. We use a manufacturing process called 3D Crosspoint. We have quite some experience with this already. We use those in SSDs as well. And now we've brought that into the DRAM segment. Yes, and because we can produce them very costly, we can offer them for a really attractive price, and this is why automatically the TCO goes down as well. But due simply to the size of the DIMMs, you can come up with some really good use cases too, where you can do consolidation, for example, and then the TCO goes down even more. So it's not only the fact that they're cheaper, but also because you can do some really good, unique use cases with that. So if you look at the scheme of memory and storage, where does this fit? So you have the cold data or classic HDD drives and SSDs. You're well familiar with those. They've been on the market for a long time. There is downside. They are fairly slow. They're cheap, but they're slow. And if you go to DRAM, they're really very fast, but expensive, right? Especially if you look at a standard 128 DIMM, it is costly exercise. We've been working to fill that gap. So the Optane DC persistent memory module is close to DRAM speed. It's not quite there, but it's very close. And the SAP HANA database knows how to optimize that. We've been working very hard with SAP to do that, to hide that small performance decrease. So in practice, we average between 0 and 6% performance decrease, but in general, the end user doesn't know any difference. So even if the database grows to 24 terabyte, the performance is still there. So that's the good thing about that. We're not going to spend time on this today, but we also have a product called Optane DC SSDs, which use the same technology, but they are not in a DIMM form factor. These come on the PCI Express interface, multiple form factors. Why is that interesting? If you compare those to standard SSDs, they are still significantly faster and lower in endurance, between 10 up to 60 times faster. Okay? So let's look at some of the use cases and advantages that this new technology brings along, and we'll look into 3 areas. Business continuity is an area that we'll look into. The memory capacity on its own is interesting, and of course the lower TCO that all these new technologies bring with it. So let's look at the SAP HANA database. So the HANA 2 Service Pack 3 was, who knows, when was it launched? Do you remember? Last Sapphire, it's easy to remember. It was 1 year ago. SAP launched HANA 2 Service Pack 3. That release of the software already fully supported Optane DC persistent memory. So from a software perspective, it was fully aware of the underlying hardware and is able to distinguish between standard DRAM and persistent DRAM. The database is designed as such that 90 to 95% of the column store sits on the persistent part of the DRAM. The volatile part and the delta of the column store and the row store still resides on DRAM, simply because you take advantage of the better performance. So you can imagine what happens if you have a power outage. Those 5 to 10% are lost. You need to rebuild that part of the memory. But the persistent part is available instantly. So you've seen some of the numbers, and I'll show that on the next slide. We've done several several POCs internally, but also with end customers, and the results were always astonishingly very similar. So in this case, we've done 4-socket, 6 terabyte instance of HANA using standard DRAM and then comparing it to the Optane DC persistent memory version, and we found that it's 12x faster. So instead of 50 minutes rebuilding, only took like 4 minutes. And we've done a similar POC with an end customer, in this case Evonik, and the findings were even better. They had an instance of HANA with 1 to 3 terabyte, took them 27 minutes previously, and after that only 95 seconds. So you can see, well, you could say, well, we don't do maintenance work frequently, but from an IT administrator perspective, it brings a huge advantage. There's no more time for coffee, by the way. Coffee breaks are over. But there are other use cases that you can think of when it comes to replication. So, as you're aware, if you have multiple instances of HANA, every single instance has to have a backup. Now, because you have additional capacity available, you can consolidate all those backup solutions into one node. So you can have a HANA instance right here. You can do all the consolidation onto a single node. Brings 2 advantages, right? It's cheaper because you need less hardware. But on top of that, the performance of that node is higher than using a standard backup node. Right. Looking at use cases with increased capacity. So HANA 2 Service Pack 3 introduced a new feature called extension node. It's not widely used yet, but we've done an exercise with Intel IT. And what you can do here is extension node basically manages your warm data, but because you have more capacity available and you can move it into a large node, this allows you to do real-time analytics. You can do AI and machine learning workloads in the background without losing performance. Right. This is an example of what one of those extension nodes might look like. So here you have an example of 4 sockets fully populated. As you can see, you're not by design, you cannot just use Intel Optane DC persistent memory. There's always an element of standard DRAM that you need in order to meet the performance. But you can see by the ratios, you can bump it up to 15 terabyte easily, and you will not lose performance for that extension node. Right. So another use case, which is similar to the one I showed previously, only that we're not looking at the backup system now, but if you have smaller instances of HANA, you could consolidate those into a single node up front because you have more space capacity available. You have enough room to do 2 or 3 instances of HANA on a single node, right? So this is something that Intel IT has done in the last few months, and we found some amazing results in that respect. So we had older solutions out there with 4 sockets, 3 terabytes. We basically took those 3 instances of HANA, put them on a single node, which was then 4 sockets and 4.5 terabyte. Not only that we saved hardware cost, but the performance was 2.4 times faster too, better too. So you have the performance gain, plus you have hardware saving costs. So we actually are migrating our internal IT to this now. So I hope that was quick and easy. I hope it wasn't too fast. If you have any questions, feel free to contact me.